Please understand that the Laplace equation, which was del square phi is equal to 0, will be written in all three coordinate system. So I did in Cartesian, then we can do in spherical polar, depending on the symmetry of the system, spherical polar, and then also we can do in cylindrical coordinate systems. Okay. So Laplace equation can be handled in all three coordinate system. The first one was the Cartesian coordinate system that I did. And please see, I gave you one thing I gave you from Griffith. I gave you a snap of all the formulas that we will be using. You remember that? Aapne?
Yes, sir.
Yes? Have you noted it down or pasted it in your copy? Because that will be used again and again, I told you. Yes or no?
Yes, sir.
So like if I take the spherical polar coordinate system, spherical coordinate system, then del square phi is equal to 0 can be written as the Laplace equation will be like this: 1 by r square del by del r, then r square del phi by del r, the potential. Okay. And then plus 1 by r sine theta. Okay. And del by del theta of sine theta, del by del theta. And then the phi one, the last term will be related to phi. So let us take azimuthal symmetry and put that equal to 0. So I'm not taking the change in azimuthal angle. Okay. In most of the cases, we do like that. So in this case, what will happen? Your potential is only function of r and theta. And when we solve this equation using variable separable technique, which technique? Variable separable technique, that I will discuss you in partial differential equation. The variable separable technique, how it works. So the potential, that means the solution, is given by summation. Please see this. So we write the solution in the form of n, and that is given by L is equal to 0 to infinity AL r to the power L plus BL upon r to the power L plus 1 into PL cos theta. PL cos theta. So this is what the solution looks like. It is very symmetrical, so we can remember it very, very easily. Please see this. This is the radial part, which depends on small r, and this is the theta part, which depends on theta. And what is PL? PL is Legendre's polynomial. Legendre's polynomial. So you should know few polynomials. I will teach that this also in a special function chapter. The Legendre polynomial. Legendre, Hermite, Bessel, Laguerre, all polynomials I will teach. And this PL is Legendre polynomial P0x. क्या होता है? 1. P1x, x. P2x, 1 by 2, 3x square minus 1. Just note down this. I will come in details while teaching you Legendre polynomial. Just note down this.
सर लास्ट टर्म क्या है? P2x.
हाफ 3x स्क्वायर माइनस 1।
ओके.
इस टॉपिक को पढ़ते समय wherever you feel difficulty, please tell me. Because बाद में अगर ये वाली चीजें पूछोगे तो it will become difficult. So this is the radial part. This is the, so because your potential depends on r and theta. So the first term is only function of small r and the second function term is only function of theta. Is that okay? समझ आ रहा है सबको? So this is the spherical. Now let us see how the questions are asked on this. Let us do the first question. ये सबको याद हो गया? Symmetrical है? L runs from 0 to infinity. AL r to the power L plus BL upon r to the power L plus 1. Here PL cos theta. Is that okay?
Yes, sir.
So let us solve questions on this. Consider a hollow metallic sphere of radius r. This is hollow. इस साइड से दिखाई देता है क्या जब मैं ऐसे खड़ा होता हूं?
Yes, sir.
Hollow metallic sphere of radius is equal to capital R. Hollow metallic sphere of radius capital R. Okay. The outer layer is at a potential. The outer layer is at potential given as some V potential of theta. Some V naught actually. Potential of theta. I mean function of theta. So the outer surface is at a same potential. I mean the whole of the outer surface is at the same potential and that potential is given by V naught theta. Is that clear? Calculate the potential at a point P inside the sphere. So what is potential at point P? This is the question. Is that okay? ठीक है भाई?
Yes, sir.
So this region is charge free. So I can apply del square phi is equal to 0. Yes or no? For the potential, Laplace equation will be valid. Laplace equation सही है. देखना बहुत ध्यान से, it's very interesting. And we know that the solution of Laplace equation, which coordinate system should I use for this sphere?
Spherical polar.
Spherical polar.
Spherical polar. So let me write that phi is equal to summation L is equal to 0 to infinity AL R to the power L plus BL by R to the power L plus 1 into PL cos of theta. Am I right? This is okay? This will be the
Yes,
potential
sir.
because this is the solution of Laplace equation in a spherical polar coordinate system without phi. There is no dependence on phi. Now please see, as a boundary condition, we have to calculate potential inside the sphere and origin is also inside the sphere. So if I come to origin, because of this term, our potential at origin coming from any angle, it will become infinity, yes or no? But if I come to this point at origin, what will happen? This is in the denominator. So if you put r is equal to 0, this term will become 0. That is okay. But this term will become infinite, yes or no?
Yes, sir.
Yes, sir.
So that means that BL should not exist because potential cannot be infinite. So this boundary condition suggests that BL should not exist and our potential, this is very interesting, summation L is equal to 0 to infinity AL R to the power L into PL cos theta. It will become like this. Got it? तो ये टर्म प्रॉब्लम क्रिएट कर रहा है r इज इक्वल टू 0 पे, इसका मतलब ये टर्म रहेगा ही नहीं. दिस इज द नीड ऑफ बाउंड्री कंडीशन. So boundary condition suggests that since it is becoming infinity at 0, so that means we should remove this term. This term should not exist because our potential cannot be infinite at the center. समझ आया सबको? Now you need more boundary conditions. To get this AL. So like it is given that potential is V naught outside. So क्या करेंगे? Let's put R is equal to capital R. So this will become phi
R,
capital R theta. This will become, this has been given equal to V naught theta, right? Some function of theta. And this will become summation L is equal to 0 to infinity AL R to the power L and PL cos of theta. Correct? समझ आ रहा? So from this equation we will calculate the value of AL. इस equation से किसकी value निकाल लेंगे?
AL.
AL की value निकाल लेंगे. So how we get the value of AL?
पोटेंशियल थीटा का टर्म है तो रेडियल टर्म नहीं होना चाहिए.
नहीं ऐसा क्यों? ये तो boundary पे है, it is V naught theta ना? When you have, so this has become constant na, capital R. Now we have to get AL. I am asking you how to get AL. So how to get AL? Anybody can suggest? Multiply both sides by PL cos theta. So this will become, this is equal to summation L is equal to 0 to infinity AL R to the power L PL square cos theta. This will become PL square cos theta. And now you have multiplied PL cos theta on both sides and now integrate it. So when you integrate it, AL will become a separate quantity and you can get the value of AL. Okay? AL we can calculate now from here. समझ आ रहा है?
Sir, after integration, PL square cos square theta vanishes.
No, why?
No, now we have seen that we get AL after integration.
No. Why PL square will not vanish? This will become,
Why?
this will get a fixed value. So you remember this from legendary polynomial -1 to 1?
2 by 12.
-1 to 1 PL x PM x. Okay? dx is equal to 2 upon 2L plus 1 if L is
Delta.
equal to M. Kronecker delta और लिख लो ना. You can write Kronecker delta. So when both are equal to 1, then you will get something. If they are not equal to 1, you will not get something. So after integration, we will get the value of AL. Okay? So this is the general form. Now coming to a particular case, like if I take a question, suppose, तो ज़्यादा आसान होगा समझाना. So suppose I take a question in which it is given. Please see this. This you will find it very interesting. So suppose in a question it is given V naught theta. It is given. Suppose it is equal to K sine square theta by 2. Suppose it is given. Sorry. Okay. So how you can write this? K. Anybody remembers how to write this? 1 minus cos theta
Cos 2.
by 2.
By 2.
It will become this. Now please see here. Put it here. So you will get K by 2 minus K by 2 cos theta is equal to, यहाँ ओपन कर लो, A0 P0 cos theta plus A1 R to the power 1 P1 cos theta plus A2 R to the power 2 P2 cos theta plus dash dash dash. Yes. So when question comes, it becomes very easy. Just you have to compare the coefficients. So K by 2 minus K by 2 cos theta is equal to, पहला term है A naught because P naught is 1. Second term is A1 R. P1 cos theta is cos theta and other terms are plus A2 R square. What is P2 cos theta?
Half
1
3
by
cos square theta minus 1.
half 3 cos square theta minus 1. Check करना जरा. Is it okay? compare the coefficients. Constant will be compared from constant. So what will be A1? पहले बताओ. A1R क्या होगा? Minus K by 2.
K by
minus k by 2.
A2?
0.
इसके आगे के सारे 0 हो जाएंगे ना. A3, A4 and A0 K by 2.
yes sir.
So write the potential in general. What is the value? Phi r comma theta क्या होगा? A0. First term was what? You remember this, na? Summation L is equal to 0 to infinity AL r to the power L into PL cos theta. यही तो था. So let us write the final answer. So first term is A0. So that is K by 2. Second term is A1. What is A1? Minus K by 2R. That is A1. A1 into R to the power 1. So it will become R. And P1 cos theta, which will become cos theta. So this is the solution at a point phi R comma theta. Is a very nice question we have solved. So just by comparing the coefficients of cos, comparing the coefficients of cos on both sides. On both sides. एक बार चेक करो, देखो समझ आ रहा है सबको?
सर थर्ड टर्म में जब अगर हम ओपन करते हैं थर्ड टर्म को A2R स्क्वायर टर्म को,
हम्म
सेकंड पार्ट है उसका A2R स्क्वायर का अपॉन 2, उसके बाद भी तो cos थीटा देंगे तो उसको कंपेयर नहीं हम मतलब कर सकते थे
फिर
K
से
बाई
फिर से पूछो क्या?
थर्ड टर्म है जो A2R स्क्वायर बाई 2 वाली, सब सर ऊपर एंड A0 प्लस A1R cos थीटा ऊपर सर, ये दिस टर्म।
तो इस तरफ ढूंढो cos स्क्वायर थीटा कहाँ है कंपेयर करने के लिए.
सर नहीं -1 भी है ना उसके साथ.
तो जब तुम इसको कंपेयर करोगे A2,
यस सर.
तो ही वो 0 हो गया.
ओके यस.
तो जब A2 0 हो गया तो यहाँ पे मल्टीप्लाई हुआ नहीं हुआ फर्क नहीं पड़ा ना.
सर A1 वाले टर्म भी एक बार बता दो.
कंपेयर करो. दिस इज cos थीटा, दिस इज cos थीटा. So A1R should be equal to minus K by 2. So
हाँ जी
A1R
सर.
should be equal to minus K by 2. So A1 is minus K by 2R. A1 is minus K by 2R.
हाँ जी
देखो
सर. ओके.
हो गया ना.
हाँ जी सर.
आराम से पूछो देख के, बिकॉज इसमें वन जब हम पहली बार हैंडल करते हैं बाउंड्री कंडीशंस कैसे लग रही हैं, कैसे वैल्यू पुट की जा रही हैं, सो इट्स लिटिल ट्रिकी. बट आपके एग्जाम में वो ऐसा देते हैं कि आप कॉस के फॉर्म में लिख लो. समझ रहे हो बात को या नहीं? दे ऑलवेज गिव दिस सो दैट यू कैन राइट इट इन दिस फॉर्म. और अगर कॉम्प्लिकेटेड फंक्शन दे दें देन हमें सिर्फ इंटीग्रेशन ही एक तरीका बचता है कि दोनों तरफ उस p से मल्टीप्लाई करके और हम इंटीग्रेट करें, तो वो काफी बड़ा हो जाता है, तो वो एग्जाम के लिए सुटेबल नहीं है. Anybody wants to ask anything, please feel free and you can discuss with me. So shall I move to next question? Consider a hollow metallic sphere of radius A, and this is kept at constant potential V naught. Calculate potential at P at a distance R. R is greater than A. Very nice question. So whenever charge is not given, on the boundaries potential is given, only way will be Laplace equation. Are you getting it or not? Because there is no charge given. Please see, just the potential is given on the surface. This is having potential V naught. And you have to find out potential at a point that is outside the spherical shell. So let me write again what is our knowledge of such type of potential from Laplace equation. Again, in a spherical polar coordinate system, L is equal to 0 to infinity. A L R to the power L plus BL over R to the power L plus 1 PL cos theta. अब समझ में आया कैसे याद हो जाता है? आप लोग की आवाज नहीं आ रही भाई, सुनाई दे रहा है?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
So are you able to understand? This is so symmetric to remember.
Yes, sir.
Now previous case में क्या था कि R was inside, so it could come to the center. Can this point come to the center? Answer me जल्दी से.
No.
Parampreet?
No, sir.
No. Raman?
Potential is there.
Raman, can you tell? Can this point come to center? No. Because this is outside, na? So it can't come to the center, right? So, but it can go to infinity? Answer
Yes,
this
sir.
question.
Yes,
Yes,
sir.
sir.
It can go in.
So if it
Yes.
will go to infinity, now this term will make the potential infinity. At R tending towards infinity, our potential will become infinity. Yes or no? Because of which term? This term. Because here R is in the numerator. So that implies that AL should not exist. ये देखो, ये समझ आ रहा है? अभी पीछे मैंने दूसरा किया था, अब दूसरा कर रहा
Yes,
हूँ.
sir.
So then your potential can be written as summation L is equal to 0 to infinity BL upon R to the power L plus 1 and PL cos of theta. Yes or no? AL has gone to 0 now. Now apply the second boundary condition. At R goes to A, potential becomes V naught. Am I right?
Yes, sir.
This is the boundary condition that is given. This is the boundary condition that is given. So if apply this case, then V naught will become summation L is equal to 0 to infinity BL upon A L plus 1 and PL cos theta. Can I write it like this?
Yes.
So now this will become V naught is equal to B naught upon A P naught cos theta plus B1 upon A square P1 cos theta plus dash dash dash. इस साइड क्या लिखा हुआ है? 1 1 into V naught है ना? And what is 1?
Yes, sir.
It is P naught cos of theta. I have told you na, P naught x is, what is P naught x? 1. So now these terms are not present. P1, P2, P3, because there is no other term. If you compare, only P naught cos theta is there. इसको compare कर सकते हो. So your V naught will become B naught by A. That means only B naught will exist, and that is A V naught. Understand this. All other coefficients will become 0. P1 is equal to P2 is equal to dash dash dash. All of them will become 0. So now again, if you put it here with only one term, phi r theta will become A V naught by R and P naught cos theta, which is 1. So this is the potential. देखो कितना अच्छा क्वेश्चन है, बिल्कुल short and sweet. So this is a previous year question. देखो समझ आता है? Is it okay?
Yes, sir.
Anything you want to ask? Please, you can ask. इसमें कोई doubt है तो?
सर
हम्म.
लास्ट में हमने कैसे लिखा, मतलब बी नॉट ए बी नॉट की वैल्यू हम फाइनल एक्सप्रेशन में सब्स्टिट्यूट करेंगे या
क्या 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 कह रहे हो?
नहीं सर, समझ में आया, सॉरी क्लियर हो गया।
1 की जगह P नॉट cos थीटा लिख दो, या यहां भी 1 लिख दो, यहां भी 1 लिख दो, दोनों कंपेयर कर लो. इसके आगे जो P1 cos थीटा है वो cos थीटा है, तो इस साइड कोई cos थीटा है नहीं, तो इसलिए ये सब आगे वाले 0 होते जाएंगे. चलो इस पे एक और क्वेश्चन करें. The electrostatic potential in some region which is charge free is given by this. In a charge free region. So FR will look like what? This is the question. Very simple question actually. Potential is like this. It is in charge free region. So it is in charge free region. So I can apply Laplace equation, yes or no? And what is the solution of Laplace equation? Tell me. It is summation. अब तो याद हो गया होगा. AL R to the power L plus PL by R to the power L plus 1 into PL cos of theta. Now they are saying that it has only formed this cos theta. So how you will write? You will write it as FR cos theta is equal to, write it here, open it, A0 plus B0 by R into P0 cos theta plus A1 plus B1 by R square into P1 cos theta. And because here you have only cos theta, so I am not going beyond P1 because P1 के बाद cos square theta आ जाता है, right? और उसके आगे cos cube.
Sir, A1R, right?
R आएगा.
A1R, correct. A1R. So when you write f of R cos of theta, you will write, this is 1. P0 is what? 1. So you have A0 plus B0 by R. And P1 cos theta is what? It is cos theta, right? P1 cos theta is cos theta. So it will become A1 R cos theta plus B1 by R square cos of theta. Yes or no?
So FR is equal to A1 plus B1 R square.
So if you compare the coefficients of cos theta, then FR will become A1 R
R plus
plus
B1 upon R
B1
square.
by R square. Nice question, na? So just you have to, they just test the basics. They can't go beyond too much because lot of calculations cannot be done, na? You have to do it in 3 to 4 minutes. So how much you can do? Even this much requires complete understanding of Laplace equation. इसमें किसी को कोई बात हो तो फटाफट पूछ लो. इसका मतलब क्लियर है, हाँ? चलो फिर इसके बाद नेक्स्ट क्लास से पढ़ेंगे. थैंक यू सो मच.
Thank you, sir.
थैंक
Thank you, sir.